The topic of our paper is damage failure transition in titanium alloy Ti-6Al-4V under dwell fatigue loads. The role of structural features of titanium-based alloys, which responsible for the staging of damage failure transition in low cycle fatigue and dwell fatigue regimes, is considered. In this work, we investigate a plate made of Ti-6Al-4V titanium alloy. The low cycle fatigue tests were performed for specimens cut from a plate of titanium alloy in the longitudinal and transverse directions. The low cycle fatigue characteristics were studied using the LFMZ test machine. Test conditions and low cycle fatigue results for different specimens under normal cyclic and dwell loading conditions are presented. In Table 2, low cycle fatigue tests in a soft cycle loading mode with a dwell period of 2, 5, 10 and 20 minutes in the loading cycle were conducted in accordance with ASTM standard. The scanning electron microscopy and fractographic studies were carried out using the Quanta 200 microscope equipped with Pegasus system and the Tascam mirror microscope equipped with field thermal emission gun and the Oxford system. Typical examples of fractographic patterns after low cycle fatigue tests are shown in Fig. 3. The developed concept of modeling of titanium alloys based on the duality of damage kinetics in dwell fatigue loading regime allowed us to elaborate the strategy of structural study, which is expected to substantiate the relationship between the structural parameters of alpha, beta phases and the phenomenological parameters that govern different mechanisms of damage accumulation in the low cycle fatigue and stress hold regime.